Got a quick demonstration here in Femap on how to set gap elements for coincident nodes. Let's see, let's make our property here new. Just call this gap. We're going to give these, they're going to work only in compression for this particular situation, so we're going to give this kind of a large value, 1 e to the 9. And we want to make sure we select this orientation coordinate system here. It could be global or any sort of orientation system you want, but we're going to just stick with global because we don't need to do anything additional at that point. And then we're not going to deal with the gap or tension stiffness because we do want these to pull away. You can add friction if you like. Just click OK. Then cancel out of that. So now we got our gap elements now, or we got the properties for our gap elements. Now we're going to create our gap elements. So we're going to go mesh, connect, coincident link. And there's a few things we could do here depending on the complexity of the model. This model is simple enough. We can just do like select all, or I can do like a pick box selection to get just the entities here, or sloppily get more entities because it's only going to look for coincident points. So I click OK and see here it is looking for the tolerance for coincident nodes. And then we'll click OK. So it's identified some. We're going to change this to gap. It's going to select our property there, gap. We need to define a vector here. For the line orientation isn't going to affect the results, but Femap is going to complain if there's not any sort of orientation defined. So we're going to click vector. We're going to just go with the default, which is 0, 1, so it's the X direction. Click OK, and so that's all we really need to do. Make sure we have gap selected and click OK. Now we have gap elements for our model. We should be able to just run this. This should be really quick. Here we go. It's finished. We're going to select the last one. The other two are experiments, troubleshooting, fun stuff like that. Because it never works right the first time you do it. Let's turn on contour. So there, we can see we get deflection. Loads from one to the other in contact. These are two shell elements in an edge-to-edge sort of situation. This was a linear static analysis. Thank you.